All right. So give me a hi, hello, how you doing in the chat, and it'll record that you were in class, and I do appreciate that. Let's go over schedule first, and then we will get right into it. Okay, I need to save this. Gosh, I'm a mess. All right, let's just go ahead and open that for tomorrow. Okay, those are some notes for the final. All right, let's get into the schedule here. Okay, so it looks like someone made up their exam too. I appreciate that. I will get that graded tonight or tomorrow. Catching up on late work myself. Okay, so what we had due today was section 15, part 1 and 2, and quiz over 13 through 15. That's due tonight. I said it due tonight because I knew we had a lot going on. So if you haven't completed it, please complete it by tonight. Okay? So that'll need to be done. You don't care about my in-person class, so let's take that away. What's going on for us this week is we have section 16's part 1 and 2. We're going to go over that together. Section 17, we're going to go over that. That's the last section of the class is 17. 17 for us is just about dead easy, but I'm going to go over the homework and show you there's only about one question I think might be confusing. So we'll do that one together. And then on Sunday, because it's the last day of the semester, we don't have till Tuesday, is exam 3, final exam review, and partial credit. Okay, so that's all due by Sunday. Normally you'd have till Tuesday, but the semester ends, so we have to do that. But I'm going to set everything up as for success as best I can. Okay, so I have some review for you that you can use if you want, and then I have some solutions you can use if you want. Okay, so maybe I'll go over that first because it did look like somebody had have to go in the middle of class. So I'm going to go to the modules. Maybe I'll go into student view, so I'll have the same view as you do. We'll go into modules here. Okay, and let's go down. So, of course, the final exam is due Sunday, and that is the biggest amount of points for the whole semester, so we can't forget it. I have some practice material for you if you want it. This is not graded. You don't submit it. You don't need to submit it, but it's there if you want. It's something that I give my in-person folks since we have more time together. I can spend more time reviewing with them. And in fact, that's going to happen today in my in-person class. We're going to begin reviewing for the exam. What I have for you, if you want it, is I have a recording of me going over it with a class. So this class, we went over it over 2 sessions of just exam review. Okay, and they did very well. The first review starts at timestamp 117, but notice the audio cut out for the first 2 minutes. So that's kind of annoying. So I guess really it's going to start at 119. And I go over one of the reviews problem for problem. Okay. And you'll hear the other students ask questions and make comments and that kind of thing. And then here is another review, a whole class session where we just reviewed. We went over 3 test reviews in this class because we had the time. So in that system, we had the time. These are the test reviews here. These are the answers to the test reviews. Okay, so you have the solutions there. Where is this located? Under practice material for exam 3. It's not graded. It's just extra if you want it. Okay, I hope you do want it, but it's there if you want it. Okay, so that's in modules, and it's under the last module, which is exam 3, sometimes referred to as exam 3. The final exam review is different, and it's been different for the past, oh, I don't know, year and a half or so, maybe 2 years. The review for the class is not run by me. So the test review for the final exam is graded. It's a graded thing, but it's not run by me. So it's run by the state. Okay, so it's the state headquarters, Ivy Tech. They run it. So it's all central office. Okay. And it's listed under your dashboard for outcomes. So this is what it will look like on your dashboard in Ivy Learn. When I say dashboard, I mean this. So the front page that you have. Spring 2024 Math 123 outcomes. There's only one assignment in there for you, and that's exam 3 review. Okay, that's all that's in there. That's all you need to do. You have 2 attempts to do it, and it's 70 minutes to complete. Okay. Um, it's not run by me. So it's something that you have to do. It's part of your final grade, but it's not run by me. So I can't really tell you that much about it. The best I can tell you is where it's located and that you have 70 minutes to complete it. In the past, it's been around 20 questions, something like that. But um, that's the best I can tell you. So it's run by central office. Okay, it's not run by me. And your grade will be recorded and then it'll be transferred. When I'm doing final grades, it'll transfer. Okay, I just realized, I'm sorry, a little bit of a tangent. I think I'm giving myself a digital thumbs up by thumbs down. I just realized last week I noticed that somebody gave me a thumbs up, but I think maybe it was myself. Maybe I'm giving myself a thumbs up. Anyway, getting used to my virtual reality world. Anyway, so spring 2024 math 123 outcomes review is recorded. It is part of that 5% of your final grade that we talked about. So 5% of your final grade goes into the reviews, and that's part of it. Okay. So you have to do it. It is graded and it is transferred on next week when we do final grades. Okay. But that's kind of weird because it's not inside our course shell. It's not run by your instructor, me. That's very strange. Okay. Um, but I can say that when I was in your shoes, that was more common than it is now. And maybe it's becoming more common. When I at a high school, I went to community college and I my English, I had English exams. We had like these timed exams in my English class, and they were run by the department. And if you failed one of those exams, you failed the class, even if you had an A in the class. So those were the written exam, or they would give you a prompt and you had to write an essay like on the spot. Um, you could have a dictionary, and that was it. So they give you a prompt, maybe you had 4 or 5 to choose from, and you just had to write an essay in a time scenario, and then submit it, and then the department would grade you. And if you failed that, you'd fail the class. And that was kind of scary. And I remember really being scared. And I did know people that failed that exam and failed the class, even though they had a B in the class. And that was really upsetting. So they had to take the class again. And that was really upsetting for them. And I squeaked by when I took it. I don't think I did that well, but I passed. It was really just a pass fail thing. That's not quite as serious as this. And I've had students since then kind of overemphasize their studying on this. I need you to complete it, but it's not the end of the world. Okay. I've had students that are almost seem more nervous about the review than the final exam, and it should be the other way. Okay. So definitely spend more time studying for the final exam than worrying about the review. I just need you to take it at least once. Okay. Do the best you can. All right. Because if you think it's worth what, it's probably worth 1/3 of 5%. of your grade. So you need to do it, but it's not something you should lose sleep over. Okay. Really just use it as practice for your final exam. Okay. So I would just think of it as practice. You get to take it twice. It's more of just a practice run. And they get to see how people are doing. They compare campuses to one another, instructors to one another, but um, it's not something that you need to put too much pressure on. Oh, another silly story. I had that in a chemistry class too. When I was in chemistry in college, we took some standardized um, chemistry test as one of our exams. Um, I think it was in chemistry too. I took it. So I'm sure if I took those exams at my school, then everybody was taking them because I wasn't at some Ivy League school or anything. I was at a community college in my area where I grew up. So it must have been standard practice back then. So it's not uncommon. It's just a little different, and it's a little different than the way we've been doing things at Ivy Tech. And so I just thought I would mention it. I will remind you again later in the week to complete it. So please do so. Okay. Now, the exam, I'll have more to say about the exam at the end of our session today. I have all of the information that you might be interested, like how long you have to take it, how many questions there are, can you use notes, that kind of thing. I'll talk about that all at the end. Also, that'll all be written down in an announcement, which will be posted after class. Okay, so you'll get that as well. But just in case you are just on the edge of your seat, you have 180 minutes to complete the final exam, which is a lot of time, and there's 28 questions. So it's a little bit longer than your other exam, but you have a lot longer to take it. So that's good. Okay. You don't have to take the whole time. You can just submit it when you're done, but um, you have the extra time. And I know that that was something that people were struggling with exam two because exam two is a little bit shorter of time. Okay. But you'll have more time for the final exam, which is good. So there should be very little surprise if you're working towards your goal. There should be very little surprise of what's on the final exam by the time you open it. Okay. So by the time you do the homework, by the time you do the review, by the time you look at those practice tests, there's going to be very little surprise about what kind of questions are going to be on there. It's not really, um, uh, you know, there's no real trick questions on there. It's pretty standard stuff. Okay. All right. As I say, we have to get through section 16, part 1 and 2, and 17. 17's dead easy, but we still need to do it because there's still a risk that you'll have one question on the final exam about it, and we need to complete that homework. So that's what I'm going to do now. Is I'm going to go over section 16's part 1 and 2 and 17. Then I hope that I can look over the homework with you and maybe do a couple problems, especially if there's some tricky ones. We could do them together. 17, I'll probably do some of the problems with you just to make sure that it's clear of what's going on. Okay. Okay, so I need to first I need to close this. No, I don't want to save it. I had to reformat this. Okay. So this isn't in your textbook. This is just a condensed version of 16's part 1 and 2 and 17. Okay. The first part of 16 is just general probability, which you already kind of know about in your everyday life. So something that students already know about, something that most people already know about, is like what's the probability of getting the heads if you flip a quarter? Okay, most people already know that. Or what's the probability of getting an even number if you roll a dice? If you roll a die, what's the probability of getting an even number? So it's a 50-50 shot, they say. It's 50-50. Okay. So that's the idea of you got 50-50. And where the 50-50 comes from is that there's only two things that could possibly happen, and one of those will happen. So if there's only two things that can happen and one of them is guaranteed to happen, then you have 50-50 shot there. Okay. So most people know that. That's fine. If you roll a die and you want to know the probability of it getting a specific number, like the number 2, that would be 1/6. 1 out of 6 things could happen, and there's only 1, 2, so that's 1/6. And it gets more and more complicated from there, but most students start with at least the idea. They, most people know at least that 50-50 thing. Okay. There's a few phrases we have to really, really watch out for in probability. And the first one is and, which isn't too confusing, but I want to start with one that's not too confusing. And means that both things have to happen. Okay. So it's all or nothing with and. Okay. So my little story that I always tell is, let's say me and you are at the gas station and you say, "Hey, do you want anything?" I say, "Yeah. I would like a coffee and a soda." A coffee and a soda. So it sounds like I want both, right? And that's what I want. So I want coffee and a soda, which means if they don't have coffee, get me nothing. If they don't have soda, get me nothing. If you can get me both, I'll take both. That's what and means in math class and logic class. Okay. So and means it has to be both or nothing. Okay. Both have to apply. That's what and means. And that's usually how we use it in everyday language. So that's not terribly confusing. So probability only includes one item that fits both categories divided by the total. So both is the key word there. Both have to apply. Okay. So you could also say students with glasses. That's students with glasses. So we'd only be considering the people that meet both category. Okay. Both category. In my in-person class, we were kind of having fun and we were talking about Pokemon because there's a fan of Pokemon in the class. So we were talking about different types of Pokemon and they could be flying type or ground type or this types of things, but it'd have to meet two categories at once. Okay, so that you can get as silly as you want, but that's the idea. Or is a little bit different than the way we use it in everyday language. It's not too much of a stretch, and we're going to get into it of what we mean by this, but it's a little bit different than the way we say it in everyday language. So, in everyday language, again, if we were at the gas station and you said, "Hey, do you want anything?" And I said, "I would like a coffee or a soda." That sounds like I only want one thing. But in math class, that means I will either take a soda or a coffee or both. Okay. So the probability includes all items in both categories. Okay. And we're gonna get into examples. We're gonna get into what that means, but it's not one or the other. Not one or the other. That's usually how we mean it in everyday language. When I talk to my son, I say, "Hey, do you want a car snack?" Yeah. If he says this or that, I'm assuming he only wants one thing. In math class, that means we want both things, if possible. Okay. So and means they have to meet both criteria at the same time, or means we'll take one or the other or both. Okay, we're going to get into examples and we're going to clarify what that means, but it doesn't mean one or the other, is what I mean to say. Conditional probability is the most confusing of them all. It's going to change the denominator. And so, what does that do? Conditional probability, usually with an if or given that, divides by a specific category. So if I'm rolling a die and I say, given that I got an even number, what's the probability I got a 2? That changes the probability. So the probability of getting a 2 was 1/6. Because there's 6 numbers and there's 1 2 in there. So that's 1/6. Given that I got an even number, well, there's 3 even numbers, and there's still only 1, 2. So given that I got an even number, it would be 1/3. We're going to get into examples, but it changes the denominator. The conditional probability changes the denominator. So we got to watch out for this if and given that. Given that that occurred, it changes the problem. If they state it as a fact, then we have to change it. Okay? All right. Real quick, I'm just noticing if you didn't say hi in the chat, please do so. I have at least 15 students in here, and I think I only had 5 hellos. So be sure you're in there so it records that you participate in class. Let's look at an example. Find the probability of a student who watches the videos. Find the probability of a student who watches the video then passes. What's the probability that the student watches the videos and passes? Calculate the chances of someone passing if they did not watch the videos. Okay. Find the probability of a student who watches the videos. All right. We have watch videos, doesn't watch videos, passing the class, not passing the class, total. Okay. Find the probability of a student that watches videos. Okay, who watched the videos? Looks like 95 students watched the videos out of the total. So that's 95 out of the total. That's the probability. So we take the specific category that we're interested over the total and then turn it into a percent. Okay, so that's the percentage. Find the probability of a student that watches the video and passes the class. And passes the class. And passes the class. This is our first and. Watches and passes. Who's that? Watches and passes is these folks right here. They watch and pass. So that's where that 86 is coming from. They meet both criteria at the same time. Okay. They are both watching and passing. Okay. Good. Still over the total though. What's the probability they watch or pass? Now we have or. How is that different? How is just changing the word from and to or different? Well, it's not one or the other. Okay. We don't do that. It's both at the same time. Okay. Watches or passes. Okay. Who watches? 95 people watch. Who passes? 101 pass the class. Okay. Now, it's not, we can't just add those because we know that there's these people that do both at the same time. So we should subtract. We should subtract that at least so we don't overcount. Okay. So what I can do is I can take all the people that passed the class. Let me do it in order of the sentence. So if you're looking back, 95 plus 101 minus 86. And the reason why I'm going to subtract it is because I don't want to overcount because it's included in both of those numbers. So I don't want to overcount. And then I'll do over 135. And then I'm going to open my calculator and show you that that works. Okay, so 95 plus 101 minus 86 is that 110. Okay, so that's the people that watch the videos or pass. Okay, so what I can do is I can just add both of these categories up and then subtract the one that they both meet because it's included in both of those numbers, so I don't want to overcount. So we get 110. Okay, zoom in a little bit. Calculate the chances of someone passing if they did not watch the videos. If. It's so easy to miss that word unless you're used to this stuff. You really have to read it so carefully. Chances of someone passing if they did not watch the videos. I'm only going to consider people that did not watch the videos because they're telling me they didn't watch it. Okay. I always joke that you have to read probability problems like a lawyer because every single phrasing counts. Every single phrasing changes the whole problem. It changes the whole problem, which is why it's so hard for people that are learning this for a second language, third language. I've had people that I've helped. I think English was their fourth language. And you might even say math is a whole nother language unto itself, right? But I've helped some people, and I really feel for them because it's bad enough a native English speaker going to this, but imagine maybe you are a person that is English as a second language. This stuff is really hard because the phrasing is so important. Calculate the chances of someone passing if they did not watch the videos. Only considering people that did not watch the videos. Who didn't watch the videos? 40 students didn't watch them. So that's my new denominator right there. Did not watch. Who's passing and didn't watch? Passing and didn't watch is right here. 15. So 15 out of 40 for passing didn't watch. Okay, they're telling me they did not watch the videos. So we have to watch out for that. And then we give the probability just by finding the decimal and then giving the percent. Okay, that's the idea. That's how those phrases work. We're going to get into another problem, but that's that's the that's the scenario. Okay. Okay. So this one is kind of a funny one, I guess. Um, it breaks up social media platforms by generations, okay, users. I'm sure this isn't factual anymore. As soon as you deal with social media, it changes. It seems like the moment you type something about it, it's already changed because it's such a volatile uh, platform. But it's still kind of fun to see how this works. So we have Facebook, Instagram, Snapchat, Twitter, TikTok. You don't need to know anything about them to be able to solve the problem. And we have different generations here. So we have Gen Z, we have millennials, Gen X, and baby boomers. Okay. And we don't really need to, but we have broken up by the years that they are born. So this is the year they're born. So 1997. So I am a millennial, and my little sister, since there is a 13-year gap between us, is a Gen Zer. So that's kind of funny. So I'm kind of, um, they call me a cusper. I'm millennial. It depends on um, which chart you look at. I was born in 84, and sometimes 84 is the cusp for millennials to Gen X. So sometimes that, and Gen Z, she was born in 97, and sometimes she is still a millennial and sometimes not, depending on who writes it. But anyway, I'm getting off track. Um, and then baby boomers, 46 to 64. So my parents are baby boomers. Okay. All right. So that's how they break up. Now we have the platforms and we have the generations. We're going to answer some probability questions about it. Okay. Calculate the probability of selecting one random person who uses Instagram. So that's just Instagram user. Doesn't have anything to do with their generation in this problem. So one random person who uses Instagram. Well, how many Instagram users do we have? We have a total of 1749 over 7754. Okay, that's it. Let me pull up my calculator and see what percentage we would get there. 1749 divided by 7754 times 100. And I'm getting, roughly 23%. Let's call it 22.6. Okay. So that one, no special vocab word that we have to watch out for. Pretty straightforward. Find the probability of selecting a random person who uses Snapchat and Gen Z. and Gen Z. That means they meet both categories at the same time. Snapchat and Gen Z. Who's that? That's these folks right here. Okay. Snapchat and Gen Z, both at the same time. Now, find the probability of a random person. That's going to be over the total. So that's 668 over the total. Okay. Keep bumping the microphone. Apologies. I'm getting around 8.6. What is the probability? What probability is there for someone who uses TikTok or Twitter? Okay. TikTok or Twitter. All right. Who's that? So TikTok, these people here. Twitter, these people here. Now, again, I say it's so volatile of how these things work. At least all these platforms still exist. I've used this sheet for a couple of years now. They at least still exist, but I have a feeling TikTok has gone up. Twitter has probably gone down. It's not even called. I said it still exists. Technically, Twitter doesn't even exist anymore, but whatever. So we want to add these together. Plus 779. Okay, and that's over the total. Okay, clear that. 1340, 779. Can't read my own handwriting. Divided by 7754 times 100. And that'd be something like 27.3%. Okay. Now I'm sure this is boring to listen to, but hang on because the problems are going to get harder, not easier. Stay with me. If selecting from only one Facebook user, what is the probability a person is a baby boomer? If, right there, I would suggest anytime you're doing a probability problem, read it out loud to yourself because you have to read it word for word, and we're programmed these days to skim. So read them out loud to make sure you're catching all the words. If is one of our keywords. Selecting Facebook users. So we're only considering Facebook. Okay? That's all we're considering right now. What's the probability they're a baby boomer? So guaranteed they're a Facebook user. What's the probability they're a baby boomer? Here we have them. Okay? So that would be 289 over the total Facebook users. Okay? Because they promised me they're a Facebook user. 289 over 2406 times 100. I'm getting roughly 12%. Okay. What are the chances of someone being a Gen X or Gen Z? Well, in this case, you can't be in two generations at the same time, right? You can't actually be in two categories at once, especially this one. I almost could be in two categories. I'm sure someone else in this meeting also could almost be in two categories if you're on the cusp, depending on what you look at. But X and Z, you can't. That's impossible. So let's see who we have here. Okay, so we don't have to worry about overlap. So that's good. X or Z. Who do we got? We got Z here. We got Xers here. There we go. 1476 2851. And here it's just standard probability. There's no if or given that. What are the chances of someone being Gen X or Gen Z? We'll just add them up. Okay. So that's what I'm going to do. 1476 plus 2851 divided by 7754 times 100, 55.8%. Calculate the probability of selecting one person who is a millennial and uses Facebook. And, okay, that means it's both at the same time, but it's not given that. We're not going to change the denominator. Person, millennial, and Facebook. So we're still going to go over the total. But we need both at the same time. Millennial Facebook users. Okay, millennial Facebook users, according to this data, is 823. Okay, let's calculate that probability. About 10.6%. Oh, right. What is the probability of finding a Snapchat user given they are Gen X? Given. So they're stating something as a fact. These people are Gen X. So I'm not going to divide by the total. I'm going to divide by Gen Xers. Okay. How many Gen X do we have? 1476. And Snapchat users that are Gen X, because we're guaranteed these are Gen Xers, 120. Okay. About 8.1%. Okay. Find the probability of someone who is a millennial or a TikTok user. Okay, we need to be careful. It's possible that we could overcount going this way. So we need to be cautious of that because we want both want both categories but don't want to overcount. We're not given any information. It's not if that. So it's going to be over the total. Millennial TikTok users or TikTok users. So how many millennials do we have? 2557. How many TikTok users? 779. And we don't want to overcount because we have some overlap here. We have millennial TikTok users, which would be 122. Okay, so I'll just take that away so I only count it once. Go 2557 plus 779 minus 122 divided by the total times 100, 41.4%. Given all TikTok users, what are the chances they're Gen Z? Okay, so we're not going to divide by the total. We're going to divide by TikTok users. 779. And TikTok that are Gen Z, 601. I'm getting about 77.2%. So we just have to be careful about these vocab words. And, or, if, given that. Okay, so please, please, please watch out for those. Any questions, comments, or concerns? Is there any one of those you want to see done again? Okay, if not, we're going to move on. I'm going to show the homework after we're done with the lecture. I'll show the homework. So this is section 15. I'm sorry, that is incorrect. This is not section 15. This is section 16, part 2. And this has to do with tests. What kind of tests? Like, really the two tests I think about that I've had outside of, um, school. Pregnancy tests would be something that this comes up, and obviously COVID tests are kind of another example that we could have. So with pregnancy tests, I can I can say for certain that, um, like if you Google how accurate they are, at least the ones that you buy at the drugstore are 99 out of 100. Okay, so it tells the truth 99 out of 100 times, but that means one time it lies. And if enough people are taking that pregnancy test, they're taking enough times, that's going to add up of how many times you got a incorrect answer. Okay, especially since every person is born, so that means every person at one time, you know, had a parent that was pregnant. That must be true. And if if every person, every parent or soon to be parent took that pregnancy test, that's 350 million times. And if it tells a lie, 1 out of 100, that's a lot of lies that they. And so even though it's almost perfect, there's still a lot of error there. And that's something we will talk about. COVID test the same. The deal with the COVID test is that it's not perfect, and then of course things were changing pretty quickly back in 2020, 2021, that kind of thing. So even if the test is, even if it was perfect, which it wasn't, sometimes the method can change. Sticking up your nose, that can vary. Um, so there was problems with that. So it would be much less than 99 out of 100. And if 350 million people took it, they didn't. But even if it was 90% accurate, well, then that means that for every 100 people that took it, 10 people would get an incorrect answer. So they may have it, test negative. They may not have it, test positive. Things can happen. Okay. That's the kind of test we're looking at here. So it's only two things, yes or no. They are pregnant or they are not pregnant. They do have COVID or they do not have COVID. And the test is only so accurate. Okay. It's better than just guessing yourself, but it's only so accurate. So it does lie sometimes. That's why they say it might be a good idea to take more than one test, because then the probability goes down that you get incorrect. Okay. Anyway, a test for a local disease of 85% accurate when recording 1,000 people, 20% of people have the disease. So they're telling us this is a fact. They're saying 20 people have it, 20% have it. Okay. If it was a pregnancy test, that means 20% of our population that we're studying is already pregnant. We're just examining how accurate the test is. Complete the chart, then answer the following questions. Okay, so we have 1,000 people. All right. The test is only 85% accurate, but 20% have this disease. Okay, it's just some general made up disease, but that's the idea. Okay, so the first thing we should fill out is this column here. We need to fill out this column, the total column. And we know that 20% have the disease. So it's 20% of the total 1,000. Okay, how many is that? 20% of 1,000 be 200. Okay, so that's how many people have it. How many people don't have it? Well, this has to add up to 1,000. So 200 plus some unknown number equals 1,000. So I guess that has to be 800. So these add to the totals. Okay. Now let's fill out the positive result first. Okay. These people have the disease. They have it. But the test only tells the truth 85% of the time. So it's going to lie to us sometimes. It's going to lie to us 15% of the time. All right. Well, they should all test positive because they have it, but the test is only so accurate. So what we're going to do is we're going to calculate how many people get a positive test. So 200 times 0.85, because it's going to tell the truth only 85% of the time, 170. Okay. The remaining folks will test negative. Okay. Now, the sad thing is, these people have it, but they got a negative result. So this is called a false negative. These are my false negatives. False negative. This is a true positive. It is the truth, and they tested positive. These folks, false negative. Okay. Let's look over here. So the 800, these 800 people, they don't have it. They don't have it. So they should be testing negative because they don't have it. But the test is only so accurate. It's not 100% accurate. So 800 times 0.85, 680 people will test negative. Okay. This is a true negative. They should test negative because they don't have the disease. So that's accurate. That's correct. But the remaining will test positive. They don't have the disease, but they'll test positive. So let's take the difference and put them there. So there's 120 people that will test positive even though they don't have it. So this is a false positive. False positive. Okay, that was supposed to be a 2. I'm not sure what it became, but it's supposed to be a 2. There we go. That's a little better. All right, let's add them up and then we can answer some questions. So plus my 170, that's 290. Okay, so we have 290 people that tested positive. 30 plus 680, 710. Oops. Okay, so we have 710 that tested negative. Another example is a drug test. I forgot to mention that one. A drug test would also be if they're testing for a certain drug in the system in some means, you would either test positive or negative. Okay, but again, the test is only so accurate. So there's a possibility that you could test positive even though you've never even used that drug in your entire life. You could have a false positive. That's a possibility. Okay. Hopefully, they're using a test that is really, really accurate, or they'll test you more than once if that may happen. But you could get a false positive. Okay. There's a chance of that happening. There is a chance. Even if you've never consumed that drug ever in your life, never touched it, never been around it, the test is only so accurate. So that can happen. Okay? So if a person gets a positive result, so if a person gets a positive result, what are the chances they don't have the disease? Okay, positive result is what we're concerned with. So that was 290. So there's only 290 people that we're thinking of. They don't have it. Who doesn't have it? 120 got a positive result but do not have the disease. So that's 120. Okay, and then let's find that probability. So that was 120 divided by 290 times 100, roughly 41.4%. Okay. What is the probability the person has the disease if they get a negative result? So we're only concerned about people that tested negative. 710 has the disease, tested negative but has it. 30. This is always the least likely thing to happen out of any test, is to have a false negative. Okay. 4.2. So the way these tests are set up, the least likely thing to happen is to have it. Maybe that's pregnancy, maybe that's drugs in your system, maybe that's, I don't know, whatever. Have it, maybe it's a virus, maybe it's COVID, and test negative. That's the least likely thing to happen out of all of the things that could possibly happen. This is the most unfortunate for someone to test positive but not actually have it. That would be the least like, especially if it was in some relation to job or whatever. So that might be a good reason to take it more than once, but this is always the least likely thing to happen. Okay. Given a person has a negative result, what is the probability they do not have the disease? Okay. Given they have a negative result, okay, what's the probability they don't have it? 680. So quite likely. Okay. We see that would be 95.8%. Okay. What is the probability of having the disease and getting a positive result? Okay, well, that's both at the same time. Who has both at the same time? Having the disease and getting positive. That's these people right here. So these people both have it and tested positive. So that's 170 over 1,000. So that would be 17%. Okay. The bad thing about these questions is that there's so many steps. So filling in the chart is confusing the first time you see it because there's so many steps that you have to do. You have so many percentages that are thrown at you. And then right after that, we answer confusing probability questions. So at first, this is something that seems like too much, or at least with students I've worked with before, it could feel like that. Even when I wasn't the teacher, just the tutor, it felt like too much for them. So it's not even just my poor teaching skills, it's just the subject itself, okay? But the good thing is, it's the same thing over and over again. So once you get it, you've got it. That's the good thing about it, okay? The bad thing is there's so many steps. The good thing is, once you get those steps, you're good. All right, so let's talk about it one more time, just to be clear what it was we did. All right. They give us the total amount of people. They have to. I can't solve for that. So I have to be given how many people are there. All right. They have to tell me the accuracy of the test. I can't I can't find that for them. They have to give that to me. And in some way, they have to give me how many people have the disease. Okay. So I have to know that prior to be able to make this chart. Okay. They could give me a percentage or they could give me an amount. In this question, they gave me 20% have the disease. So I can fill it out. In other questions, they might just give you the amount of people and then you can work from there. Okay. In either case, it has to be given to you. Right. So there's no way you could solve for that. It's just given to you. All right. From there, fill out the chart. So you want to fill out the column first, the totals. Okay. Then I would work kind of clockwise. So your positive has the disease, negative, then negative result, positive result, then do your totals. Okay. But the bad thing is there's a lot of steps. The good thing is every question is about the same. So as I say, if you do a few problems, once you get it, you got it. Okay. Here's another one. A test measures for pregnancy is 99% accurate. And when I Google searched this for my in-person class, because I was going to talk about pregnancy tests, that's what I found too. So I don't have any better information than this. The best from my research was they're about 99%, at least the ones at the drugstore are about 99% accurate, which does leave 1% inaccurate, which you wouldn't think would be that big a deal. But if enough people take that test, it's going to, I mean, 1 out of 100. So if 350 million people take it, there's a lot of people. They're going to get inaccurate results. But it's better than just guessing. So a test measures for pregnancy 99% accurate. Survey 250 women took the test, but only 185 were actually pregnant. What are the chances that a woman was pregnant given they had a positive result? We'll deal with that at the end. We have to fill out the chart first. Okay. 250 people took the test. 185 were pregnant. I hate to say this, phrase it, has the disease, has the virus, has the child, that kind of thing. Okay. So has it is these folks. All right. Okay. So we have that. Now the test is only so accurate. So 99% will test positive. All right. So 0.99 times 185. It's 183.15. That's how many will get the positive result, even though they are indeed pregnant. And minus 1.85. Oops. Okay, there we go. Now, if we have for our study 250 people, 185 were actually pregnant, then how many people were not? 250 minus 185 is 65. Okay, there we go. Now, these people should test negative because they don't have it. Okay, so that should be the case. So we can multiply that by 99%, 64.35. Okay, minus 65, and that's only 0.65. All right, let's do our totals. 183.8. 1.85 plus 64.35, 66.2. Okay, got my chart filled out. Now, next thing, answer the question. What are the chances that a woman was pregnant given they have a positive result? So, how many people have positive results right here? All right. What's the chances they were pregnant? So, out of positive results, these people are pregnant. Go. Let's find that probability. 183.15 divided by 183.8 times 100. Find 99.6% chance. Okay, there you go. So hopefully the second example seemed a little easier than the first. The chart is about the exact same as we looked at before. So that's good. That's nice. But it is a lot. It is a lot at first to understand. The good thing is it's pretty much the same thing. Even if it's about drug tests or speeding or pregnancy test or COVID test, the chart itself is all about the same. Okay. So that's a good thing. It's really repetitive. So you can get used to this pretty quickly. All right, out of 32,000 people, 25% speed on the roads. The test is 95% accurate. What is the probability that someone of catching someone speeding given they got a negative result? Okay. So we'll deal with the actual question at the end. So let's fill out the chart first because we have to. 25% are actually speeding. I'm sure no one here in this meeting this morning will actually speed. That's only other people to do that. So 8,000 people here in this chart are speeding. Okay. So minus 32, which I think just gives me 24, are not speeding. Good for them. It seems like when I'm driving in Bloomington, most people are speeding, but in this case, only 25% are speeding. All right, now, if they're speeding, they should test positive. Okay, it's 95% accurate. So, out of the 8,000, 95% should test positive. 7,600 should test positive since they are speeding. All right. The remainder will test negative, even though they were speeding. They were speeding, but they're going to test negative because the test isn't perfect. Okay. Now, these folks are not speeding. So the majority will test negative. So 24,000 times 0.95, 22,800 test negative. The remainder will test positive even though they weren't speeding. 1,200. So these people weren't speeding, but they did get a positive result because the test isn't perfect. So hopefully they don't get a ticket, but it's unfortunate because they weren't actually speeding. 8,800. And then we have 400 plus our 22,800, 23,200. Again, you'll see the least likely thing to happen is a false negative. It's the least likely event to occur. You have a true positive. You have a false positive. And you have a true negative there. Okay. All right. Now, the question says, what is the probability of catching someone speeding given they got a negative result? Given. So let's deal with that first. That's one of our vocab words. So given they got a negative result, 23, 200. Okay. Given they got a negative result. So we're not taking out of the total, we're taking out of negative result. All right. Catching someone speeding. Well, what does that mean? Well, I'm going to guess since these people were speeding, but they got a negative result, that has to be these because these people were speeding. So that's 400. Okay. And let's go. This would be the least likely category to be in. And times 100, we have about 1.7% chance. That's the idea. Any questions, comments, or complaints about filling out the chart? Any questions? Anything you want me to show again? Okay. Before I get into section 17, which isn't that much, but 16 is a lot. So before I get into that, I'm going to go to the homework and make sure that it makes sense. Let's go to 16, part 1. Now, your questions will probably be a little different because it does randomize numbers and sometimes it randomizes phrases. So it might be a little different, but this will at least give you a head start. Betty has several of standard six-sided die, common in many board games. If Betty rolls one of these, what's the probability that she rolls a 3? So how many threes? There's 1 out of 6. Okay, so what's the probability? Write these answers as fraction in lowest terms. So that seems like that would be 1/6 chance. There's only 1 3, there's 6 numbers. What's the probability of an odd number? Well, there's 3 odd numbers, 1, 3, and 5 out of 6. So that's 3 out of 6. That's 1/2. So that'd be 1/2. What's the probability we get a 6 or an odd number? Okay, so it's, whoops, I forgot I'm in a different program now. Odd numbers, 1, 3, 5, and a 6. Okay, so that's 4 out of 6. 4 things out of 6 is 2/3. So I would put 2/3. That's the idea. All right, let's keep going and take a look. We've got some Android users, we got some iPhone users. What's the probability that someone chosen at random was aged 50, or sorry, 41 to 50? Okay, 41 to 50 over the total. Okay, this kind of reminds me of that problem we worked on with the social media platforms. What is the probability someone chosen at random was an Android user or 41 to 50? Now, we dealt with that with our social media platforms. It's both at the same time, right? So Android or 41. So we can add up all the Android, all the 41 to 50 years old, and then subtract that overlapping because we don't want to overcount, divided by the total. How are we expected to answer? We want to write all answers as a percentage without the decimal. I'm sorry, without the percent sign to 1 decimal. All right, let's just do this one together and make sure it makes sense. So what would I do? I would go 2160 plus 1459 minus their overlapping over the total. Okay. There we go. things opened at once. 2160 plus 1459 minus 1068 divided by 3742 times 100. So I would put 68.2. Okay, that's what I would do. Whoops. Maybe I should put it in the right field. Do you think that would help? That looks better. Okay, that is the idea. All right. So we did go over questions very similar to this. We went over the um, social media platforms. This is also of similar. Here you're going to total, 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 total. And I will mention, I get lots of questions about this. So you fill out the totals and then you answer questions about it. Okay. So be sure you're referring to that chart. That's something that gets confusing. Here you have another chart. It's really all the same thing. And then you have one multiple choice question at the end. Using the table of political preference and states, answer the following question. If Indiana, Ohio, and Illinois had the exact same number of independent voters, which of the following would be true? Well, you have to fill out the chart first, answer the questions, and then this will become more obvious to you. But that is the idea with the homework. Very similar to what we did in class. The lecture notes will be posted after class. Okay, let's go back. Let's look at part 2, which has to do with those tests that we were looking at. So section 16, part 2. Okay. A dog allergy test has 98% accuracy rate. Only 1% of the population is actually allergic to dogs. It's actually smaller than that. Fill in the table below and the population. So this is very similar to what we did. They tell you 1% of the population is actually allergic. So that'd be the first thing I would fill out. So I have 10,000 people times 0.01. So 100 people would go here. And the remainder would go there. Whoops. Well, what did I do? I really hit the wrong button that time. Oh my goodness. I've never done that before. Apologies, folks. All right, let's go back down. Is it 100? Yep. Minus. There we go. And the accuracy of the test is 98%. So 97. Go. Probably take out that. And so on, right? So this would be 98. And this would be 2. There you go. And so on and so on. But that's the idea. Here they tell you the amount of people, so you take the difference to find this. Accuracy of the test is 90%. Um, it's very similar to what we did, but notice that it might use. So using the previous question, it's going to use that previous table there. Using the previous table, be sure you're using that. Using the previous table, be sure you're using that. And then start out. I think these last two, you have to make the chart yourself and then answer the question. That's something that I get emails about sometimes, is that students will be like, what am I supposed to do? Fill out the chart. So you have to fill out the chart yourself and then answer the question. So at the last two questions, you're on your own to fill out the chart and answer the question. Okay. That is the idea. Okay. Sorry for the technical difficulties there. All right. What I'm going to do is I'm going to take a quick, I'm going to do 10-minute break, come back, talk about section 17. Okay. So Um, don't go anywhere. Well, come back in 10 minutes. We'll come back. We'll talk about 17. We'll look at the homework together, and then we'll talk about the test. Okay? So let's come back in 10 minutes. Hey, so hopefully you can hear me. If you can hear me, could you write your favorite movie or lately your favorite movie in the chat so it's recorded you came back? What's your favorite movie? Looks like I'm just about to get a thunderstorm. It just grumbled out there. So just in case, it hasn't happened in a long time, but in case I was to lose internet service, I will continue with the lecture and I will post it when I get internet. Okay. I don't think it'll happen, but if it does happen, I'll post it later. Okay. All right. Um, it hasn't happened in a long time, but just in case this would be a bad one, which I don't think it will be, just so you know, it'll still be posted so you can watch the remaining. Okay. So what we need to do is we need to go over section 17. And 17 is fairly easy if I explain it clear enough. It's fairly easy to do. 17 has to do with polls, random polls, sample polls of people's opinion. And it can only be of two things, yes or no, or a good example is voting, especially like presidential voting. If you only have two candidates, which we have more than one candidate, but if we only consider two, we can think of um, how accurate that poll is. Okay, so that's the idea with Section 17 is how accurate these polls are. Now, if I ask you what your favorite movie is, okay, and um, two of you say, I think I got two. Two say the Hunger Games, but only how many people answered? One, two, three, four, five, six. So two out of six answered the Hunger Games. So that means 1/3 of you like Hunger Games. Now, is that true? Probably not. It's just those that answered. Okay. So if I say, well, 1/3 of all Ivy Tech students like Hunger Games, that's their favorite movie, that's probably not true because I'm taking a small poll. I got a small amount of answers and I'm extracting it over a lot of people. And the best information I can find online is there is about 86,000 Ivy Tech students every year for the whole state. That's the best number I can find at the time. So it's kind of a leap that I would say 1/3 of those students, their favorite movie is Hunger Games because I took a poll and six people answered. So it's kind of a leap. Is there any way to quantify how wrong that is? Is there a way of actually calculating how wrong that is? And it turns out there is, and it turns out the subject itself can go really deep. And in fact, it can go a lot deeper than even I understand. That's the deal with probability and statistics is you can almost go down as far as you want to go with the subject. It can go really, really far. You can get a PhD in this in just this one part of our class. It goes really, really, really far, and it's really important. It's really important um, in our society that this becomes more truthful because as our lives become more dependent on our digital world, more statistics becomes more important, and more assumptions and inference is caused by what we do online. And all of that can have a bias and all of that can have an error. So that's a problem. And it's even more of a problem on the in the digital world than it was in the physical world. And we know in the physical world it was a big problem. Okay. There's a lot of assumptions made by people and there's a lot of bias in this world. So it's even more so there. And you can study how wrong it is. Okay. But my point today, this morning, is that the fewer people you consider, the more inaccurate you are. Okay. So if I poll 7 people, their favorite movie, and 2 of them say Hunger Games, now I have 2/7 of all Ivy Tech students like Hunger Games. Maybe, maybe that's their favorite movie, but maybe not. Is there a way to calculate how wrong that is? And there is. And then there's a way to calculate how wrong that calculation is, and we'll get into that. But that's the idea, is that you can actually quantify the accuracy of your poll. Okay. So I would say the less people I ask, the more inaccurate my poll is. The more people I ask, the more accurate it is. If I asked all Ivy Tech students, if everyone got a notification today and it said, Ryan needs to know, what's your favorite movie? And everyone had to answer. And everyone answered. And I added up all the people that answered Hunger Games over all the people that answered. I would have a really accurate answer. I would have a really accurate answer. But if I only poll a few people, it's more and more inaccurate. That's my point. Okay. So the more people you ask, the more correct your poll is. Right. So let's get into how we can quantify those ideas. So Section 17, we only have this one little paragraph we have to go over the lecture notes. Section 17 looks at error within the surveys. With these problems, we will read the results from a survey, then apply a margin of error to the percentage, add and subtract the value. Finally, we will write a sentence about the results. Example, a survey of Ivy Tech students shows that 78% of people will use quantitative reasoning after the class finishes. So it's saying that 78% of the people that take the class will use something they learned in the class after completing it. But the margin of error, so there is inaccuracy in this, the margin of error is 3.2%. So this is the error. Okay, so we talked about if I only poll 7 people, there's a certain amount of error that I'm only polling so many people. In this case, the error is given to us. We don't need to calculate it. And it's given at 3.2. Okay, so this was given that the margin of error is 3.2. We want to find the confidence interval. Okay, what on earth is the confidence interval? Okay, so let's take this. 78% will use the skills they learned in the class after the class. There's an error of 3.2%. So what we're going to do is we're going to add and subtract that error. So we take this 78, take that 78, and minus the error, which takes us to 74.8% of people will use the skills after the class. We're going to add the error to the 78. Okay, so it's 3.2% wrong. We're going to add it, and then we have 81.2% of people. So we know we're wrong, and we know how wrong we are. We know we're 3.2% inaccurate. So that means we can find this interval of correctness. Okay, so we know we're wrong, and we know how wrong we are, so we can accurately present our information. So we are 95% confident that 74.8% to 81.2% will use the skills they learned in the class after the class. Okay, so this is the error, the margin of error. And what you have to do is you have to add or subtract that to whatever percentage you're thinking of. Okay, so in this example, we didn't have to calculate the margin of error. It was given to us. Most of the time, it'll just be given to you. Okay, you won't have to calculate it. We can talk about how to calculate it if we need to, but right now we didn't need to. What on earth is with this 95% business? What's on with this 95, 95? Where's that come from? What's going on? The 95 is the most confusing thing about section 17, and the number one advice I'm going to say is don't use it, okay? You don't actually use the 95%. The 95% comes from how accurate our system is. So this is not a perfect system, and you can actually quantify how perfect it is. It's this system that we're using is also only 95% accurate. That's the problem with statistics, is that you can just keep going and going and going to more and more accuracy. But that I'll just tell you that that 95% has to do with that normal distribution that we learned last time. So you have your 68 in the middle, your 30, 13.5 on either side. And so you have this middle 95%. That's how accurate we are, that they lie within this. Here's where we are. So the best thing I can tell you is just don't use the 95%. It's almost like the title of what we're doing. So the 95% confidence interval is like the title of our confidence interval. We don't use the 95% in our calculation. So I'm going to write, don't use 95% in calc. Okay. Wow, what did it do? Okay, we don't actually use the 95%. It's the title of our confidence interval. Okay. So the scheme that we're using is the 95% confidence interval. There's other schemes out there. You can get closer and closer and closer to the truth. You can use other schemes that are like 98 point something percent. You can calculate closer to the truth. But this is the easiest version. That's why Ivy Tech chose to use the system, because all you have to do is add and subtract. Anyway, I don't want to get too into the weeds because you don't need to. Okay. So all sentences are the same. Each blank is replaced with the problem you're currently working on. For example, I am 95% confident that 74.8 to 81.2% of people will use, is it skills or math? Shows that people will use quantitative reasoning. They'll just use QR. All right, they'll just use QR after the class. Okay, so there's a 74.8 to 81.2% chance you will use some of these skills after you complete the class this week. Okay, that's what we're saying. We're 95% confident that that would happen. All right, it's confusing because we don't use the 95% other than in name only. We don't actually use it in our calculations. Okay, that's confusing, and I do apologize, but that's the system, and that's kind of the name of the game. That's statistics for you. Each thing has its own title, and those titles are of certain accuracy. So, I don't know if you've ever taken statistics, but or even if you just look at a statistics book, there's all kinds of tests, and then how accurate those tests are, hypothesis test, and then you can do different testing of, it just, the rabbit hole never ends with probability and statistics, which is good and bad. But we only need to touch on the topic. Okay. So let's see what's going on with our homework. So a 2015 Gallup poll of 1,627 adults found that only 22% felt fully engaged in their mortgage provider. What is the sample size? That's like how many people did they poll? Okay. Well, they gave that to me in the question. This many people is how many polled, so that's the sample size. Okay. The margin of error for this set is 2.5%. What is the 95% confidence interval using only one decimal? Here's the example, 32.6 to 42.9. So they're telling us how to enter it in. Okay. Well, it was 22% felt fully engaged, and we have a confidence interval. I'm sorry, we have a margin of error of 2.5. Okay, so we can calculate this by adding and subtracting. So we take that 22 minus our error, which is 19.5, to 22 plus 2.5, 24.5. Okay, so you're finding that interval. Sorry, finding the interval. Okay, adding and subtracting. I think that was supposed to be a 2. That looks better. Using the previous problem about mortgage providers, complete the sentence below interpretation of the 95% interval. I am 95% confident that 19.5 to 24.5% of people felt fully engaged by their mortgage provider. Okay, that's it. Recent poll of 1,001 American age 18 are over conducted in May of 2013 found that 80% of the respondents strongly agree K through 12 schools should teach critical thinking. What's the sample size? Sample size is how many people were polled. Okay, and they told me that's how many people were polled. For the survey, the margin of error is measured to be 3.2. What's the 95% confidence interval? That's the same thing we did last time. You just add and subtract the error. Okay, that's it. Next question is the same as what we did before. You're going to restate it. I am 95% confident that blank to blank percent people strongly agree. Okay, same thing. All right, this is all looking very similar. If a survey of a movie shows that 50% of all people who like the movie enjoy the official movie soundtrack too, the total of 3,850 people were asked to find the data in the survey. What's the sample size? The sample size is how many people were polled. So in this case, that's 3,850. Okay. If the margin of error for the survey is 1.6%, what's the interval? 95% interval. Okay, so let's find it. It's 50%, so I would add or subtract it. Okay, that's all we have to do. 50% minus 1.6% is 48.4 to 51.6. I'll just add it. Okay, that's it. All right. I am 95% confident that 48.4 to 51.6 of people like this looks like a typo, like the movie and the soundtrack. Okay. Never use the 95% in your calculations. Okay, the last one's multiple choice, so I'll leave that for you. When asking 48 students whether they liked Math 123, 78% responded with yes, with a margin of error of 14%. What can you conclude about this statement? 22 students did not like it. You can say that 78% of 48 is 37 liked it. 95% confident that 78% of students liked it. The majority of the students liked it. Okay, so what can you conclude? All right, that's multiple choice, so I'll leave that one for you. That's the idea. And the only thing I never said was how you calculate that margin of error yourself. Okay, that's the only thing I left. And if you're given a poll like that, sorry for all the flipping. If you're given a poll to find that margin of error, which it never asked you in the homework, but in case you wanted to know, you take the people that you're given, how many people were polled, You take the square root, and it's 1 over the square root. So I'm going to do the inverse. And then times 100, and that gives me 2.5% error, roughly 2.5%. And you see that's what was given in the problem. So the problem's just giving it to you, you're just using it. You didn't have to calculate it. Okay, but let me write down that formula just in case you're interested of where that comes from. So it's 1 over the square root of the number of people asked. So that's how I would calculate it. So if I go down to another problem, okay, we have 101 Americans old, so I can take the square root and then 1 over that square root times 100 gives me that percentage. So that would be roughly 3.2%. And that's what we see located right there. So in the homework, it's just given to you. It's just reported to you. There's nothing you have to calculate as far as getting the margin of error. It's just given to you. But if you're interested in where it comes from, there you go. Okay. I make my in-person do it. I make them figure out how to do it on their calculator, but online, got to give up something. So there. I told you how to do it, but you don't have to do it for the homework. Okay. Now, are there any questions I can go over about that? Is there any questions you want me to go over? Is there anything you want me to talk about again with margin of error? Is there anything that didn't make sense? I can go back to the lecture. We only have a paragraph there to go over. That's roughly it. Even in the in-person, this is not even a full lecture. So it doesn't even take me 50 minutes to go over it in the class. It's just a short. I mean, it's good that it's short because it's at the end, but it's just a touch. The only thing that's really confusing is the first time you deal with it, maybe the second time you deal with it, is that 95% because we never actually use it for our own calculations. And that's confusing. Okay. But it's like the title of the system. Okay. So that's it. I'm going to post these notes after class. So you'll get that in an announcement. Okay. But before that, is there any questions? Anything you want to see again? Doesn't make sense. So I think section 17 homework should be manageable. You got a pretty good start on it in class, so I would think that would be okay. The only one I didn't really do was the last one, so that should be okay. Okay. So if there's no questions, then I think we should talk about the exam. Okay. So let's talk about it. Now, can I talk about it without showing it? I'm pretty sure. Exam 3. This is it. So does it tell you how many questions? No, but there's 28. There's 28 questions, okay? Now, some of them have parts. Some of them look like um, that test, like a pregnancy test. It looks like that. There's a question like that on there. So that has many parts to it. So that's one question, but there's many parts to it. So is it one question or not? So you have to watch out for that. But you have 180 minutes to complete it. So it is a little bit longer, but you have a lot more time. You don't have to use that time, but you can. Okay, so that's good. Um, you can only take it once. So once you open it, that's it. You gotta go. You gotta go. It's available. It's already available. You can already take it if you want. But the last moment is March 10th at 11:59 p.m. That's it, because that's the last minute of the semester. So it has to be done by then. Now that means even if you take it at 11 p.m. Eastern Standard Time, that means you'd only have 1 hour because it will close no matter when you open it. So even if you open it late, you don't get full time. So watch out for that. Okay. That is more of an issue in some of my other classes, but it does come up every once in a while here. So it'll close no matter when you opened, it'll close then. Okay, so start earlier so you get full time, right? 28 questions. It does cover everything, but in truth, it doesn't cover everything. So in truth, it focuses on the newer material. So really, it's going to focus on sections, mm, really 13 through 17 is what it focuses on. But we can see that when we look at the review. You do want to use the formula sheet. This is posted in the exam. So when you open the exam, you will have this. This part will be located at the top of your page. Okay, so you'll have those. You want to use these units, these numbers for your calculation. Um, don't use something you Googled before um, because everything is based off of these conversions. So be sure to use those. You have your conversion formula here, CO2 right there. And also your probability with Z score, that kind of thing. You don't have to have that memorized, but you'll need to refer to it during the test. You'll use these numbers just like you did in the homework. And this is posted in the exam. So you can have your physical copy if you want. And then you also have this when you open the exam, that will be there. And then here's a PDF copy if you want another digital copy. But you will want to refer to that during the test because I assume you don't have pounds to kilograms memorized. I don't expect you to. So there it is. It's in the test. Okay. So you can just scroll up to the top of the page when you take the test and refer to it. And be sure to turn in your partial credit, your partial scratch paper. Okay. We need to make sure that you turn this in. This, even though um, there's no official extra credit in the class. This is the best way to improve your grade for the whole semester, other than just doing the best you can on a test. Okay. So if you turn in the partial credit, then I can give you partial credit. Okay. I will grade every question for every person by hand to make sure that it was graded correctly. Make sure it didn't grade you incorrectly. Um, but beyond that, I had to have something submitted from you to give you partial credit. Okay, so if you were on the right track or something like that, I can refer to your work and give you something. So let me be sure that this is graded for you because you want to turn this in, even though it's technically worth 0 points. Okay, so it's technically worth 0 points, but it's not really worth 0 points because I can give you partial credit on your exam and your exam is worth 25% of your grade. So I'm going to leave this due when the test closes, but I'm also going to leave it available. So if you need to, you could still turn it in on Monday and get some partial credit, okay? But I don't want you to be too late. Um, Here, let me put some kind of boundary on there because I have to have grades done by Tuesday. I'm gonna have to have that. Okay. So you could still turn in the partial credit at some point. I don't want you to have to like try to get the test done early so you can whatever. But that's the idea. Okay. So that's the test. 28 questions. You have 180 minutes to do it. It's very similar to the other ones. What's different this time is that the review is totally different. Now, because of um, our particular schedule, we didn't even have an assigned review for exam two. I didn't even assign it. It was if you wanted to or not. I still have that. This is the practice material for exam three. This is the same I go over in my in-person class, and there's even a recording of the in-person class. The final exam review is the same one that everyone has to take for the state, and you can take it twice. and I don't have control over it. So you will take it at least once. You can take it twice to improve your, or take it another time to improve your grade. It does randomize the questions, so watch out for that. So you might get different questions the second time. Um, you can use your notes during the review, so be sure of that. But I would use it as a practice run. Use it as a practice run for the real exam. Okay, so do a trial run. Do set up yourself for success. Try it, see how you do, and then see what you wish you would have studied for, and then you can go back and do that. Okay. So exam 3 is due on March 10th. Partial credit is due March 10th, but I'll take it the next day because I guarantee you I will be in the office grading that day, so I'll still have plenty to do. And as I said, with the practice material for exam 3, it's a little bit different because, I mean, this isn't graded, but I might as well offer it to you if I can. Okay, so again, you have another formula sheet posted right there. You have 2 recordings of me going through all 3 reviews. And then here are the reviews themselves. And then here are the keys. If you don't want to hear my voice ever again, that's the keys to them. Those are the answers. So you could just look at them if you want. So that's all posted there. Okay. All right. Let's go to what you're going to get um, after class. So week 8 probability, that's what we're in now. This video that I'm inside right now is going to be posted here, lecture video. The practice material that I referred to before is also posted in the announcements, and the lecture notes are already going to be posted. So this will be all posted after class. So you'll have everything from this session after class. And then because it's so important, I'm going to make another announcement to separate the final exam a little bit. Here's all the details of the final exam, practice material, test review. Weird thing is that it's located under outcomes. It's not located in our class, and that's weird, especially in an online class, but that's the way it is. So in my shell is a little bit different than yours, but here we have outcomes. This is what you're looking for, and there should only be one assignment for you to do. Mine's going to look a little different, um, but here we go. Hopefully I can click this without showing you answers. Okay, I can. So this is it. 75 minutes. You get to take it 2 times, right? So you need to do that at least once. At least once, but you can take it twice. Okay. Okay. Now, that is a lot. Maybe too much. Okay. But hey, we're at finals and we're at 8 weeks, and that's the deal. So, what I'm going to do is I can review for the exam. But another thing I do, since we don't meet that often, we only meet 8 times, I think what I'm going to do is I'm just going to stop the recording and then I'm just going to take questions. Okay. And so I'll do whatever the people that are here want me to do, I'll do that. Okay. Because everything you need to succeed is on the course website. All right. Or at least it will be this afternoon. Okay. Once those announcements go out. All right. So as far as the recorded material, that's it. If you're watching the recording, please email me if you have any questions, comments, or concerns, and I'll get to you as soon as I can. Other than that, I wish you well. But if you have questions, if you're in person, stick around because now we're going to do a little office hour. Okay. So I'm going to stop the recording and then we can just talk some amongst ourselves. Okay.